Hello, Algebra 1s. Welcome to your last video lesson. So thank you for working so hard while I have been recovering. Looking forward to seeing you next week. Hey, if you're behind on all these videos, please make sure that you take the time to catch up. You want to make sure that that packet is finished and each of these warm-ups are turned in to Mr. McCullough. All right, last lesson we were talking about graphing inequalities on the coordinate plane, two variables. And what we're going to do this time is make a system of inequalities. So these are a whole lot of fun if you can find two different colors of pens. Right next to me, I'm always working on, you can see I have all of my pens ready to go. So if you have pens of other colors, go ahead, find a friend and share, because it's cool when you can see these work together. All right. First of all, we're going to convert line 1 to slope-intercept form by solving for a y. So my y is equal to positive 4x plus 5, because I'm going to, of course, add 4x to each side. When I look at my slope, I have a rate of change of 4 and an intercept of over 0 at 5. Hey, this is the intercept because if I put 0 in for x, do you see how this would all cancel out? So we'll go ahead and graph that line, starting at 5 over 0 at 5. Slope of 4, rise 1, 2, 3, 4. And if I wanted to go in the negative direction, negative 1, 2, 3, 4, negative 1, still gives me that rate of change. It's a positive line. It's kind of steep. And there I go. It's an equal sign, so I draw a straight line. Okay, line 2 is a vux. And I know it's a vux because I see that x. So it has an undefined slope. And it has no y-intercept. So all of my x's are negative 2. In this scenario, it's a vertical line that goes through negative 2. So there we go. When it says graph the system, I'm looking for the solution, which is always, of course, going to be where do these two lines intersect? So if I go over negative 2 and down 2, I find a point that they both share. All right, let's graph this system of equations. Not so easy for this one. I need to do some work to solve for y. So we'll go ahead and we'll add 6x to each side. So I get 3y is equal to 6x plus 12 divided by 3. So my y is equal to 2x plus 4. My slope is 2. Here it is. And my y-intercept means I go over 0 and up 1, 2, 3, 4. Because if I plug 0 in for that x, this would 0 out. All right, slope of 2. Rise 2, run 1. Rise 2, run 1. If I wanted to go backwards, I could fall 2 and go back 1. Notice each of my dots lines up. Draw my line. This line represents all of the solutions that make this equation true. When I look here at this one, I have another line. I have a slope of 2 and an intercept, again, of 4. Over 0 at 4. Uh-oh. Check it out. It ends up being the same exact line. I have an intercept of 4, and I have a slope of rise 2, run 1. So when I talk about what points make this equation true, there are infinite. So we say that there are infinite solutions. We recognize that these two lines are the same line. Every line has one slope and one intercept. And when these two were solved, I found it. And remember that word that we use, we can say, hey, these are coincident lines. Like, hey, what a coincidence, we're the same line. All right, so now I want you to go to Desmos. and I want you to, if you have not already bookmarked it, please do. I want you to type in this inequality, and I want you to find what ordered pairs are solutions. Alright, so here we are in Desmos, and I'll go ahead and up to my cursor, type in 6x. I love how the line pops up right away, minus 3y. And I'm going to go ahead and go down to my symbols here, and I'm going to choose is less than 2. And I have that lovely field of values right here. Now here's what's cool, is as I test each of these, if I wanted to, I can have the calculator graph these. So negative 5, 1, it'll show me exactly where that is. So yes, that is a solution. Now, you should be able to look at the coordinate plane and get that anyway, but when you look at where those answers are, and you can come back and take away the negative here, which is our next point. Is this a solution? No. Was that a solution? Yes. So you want to make sure that as you consider each of these solutions, we can do 1, 5 and get rid of those other ones. Now check it out. Do you see this here? If we want to, we can have it label it, and it'll go ahead and show us the XY ordered pairs right there. So is 1, 5 a solution? Yes. So you go ahead, type all these in, and check your answers back with mine. All right, check your work with mine. Now keep in mind, other than the Desmos graph, you can go ahead and take any point that you're not sure of, and remember, you can plug in that x and y. So I can say, hey, is 6 times 2 minus 3 times 0 smaller than 2? So is 12 smaller than 2? Of course not. That's why that's not. So there's 2 ways of checking solutions. Number 1 is using algebra, like we did here, and number 2 is using the graph, like you did with Desmos. All right, let's see what's on tap for today. So your tasks today, complete the warm-up and check the video with the key. Homework 512 is on the website, so you can go ahead and check that. And I really want you to reflect, where did you go wrong? It's an awful lot of learning that can happen there. Our lesson for 513 is on systems of inequalities. We're solving by graphing, and guess what? Graphing is the only way to solve a system of inequalities. After the video, you're going to check in with Mr. McCulloch, and he's going to give you a Desmos graphing activity, and then you can start your homework. Hey, pay attention to this. Tonight's homework is the last assignment in your packet. So when I see you next class, you're going to have a quiz and review, and you have all weekend to make sure you're caught up. So what I want you to make sure you're doing is keeping up with that work. The only way to learn math is to do math. Keep working hard. You can do it.